This tutorial will look at using Grasshopper for responsive architecture. And what I mean by responsive is geometry that responds to external data or external elements to manipulate form, to help aid in design or analysis. And in this tutorial we're going to look at using a daylight system that's composed of an azimuth angle, so you see there's a north arrow, and we're going to use a winter sun condition. So as I move the daylight around to the south, I want to maximize solar heat gain for passive heating. So I want the circles to get larger. So if I lower the azimuth back to north, the circles are getting smaller. And then I also want, as it becomes later in the day and that angle of the daylight moves back toward north, for the circles to decrease in size. So we have increasing radii and decreasing radii. And then the other function that's built into here is a compass size. Okay, so I'll start a new Grasshopper definition. So the first thing we need to make is the compass size. So we're going to do that using a circle. And I'll need a number slider to define the radius of that circle. And I'm going to set the slider to integers. And my maximum value is going to be 360. Okay, so there's the compass. Now I'll need the center of that circle, which is 0, 0 in the XYZ. So I'm going to double click and bring out a XYZ point that by default is 0, 0, 0, and I'll plug that into the origin or the plane for that circle. And it also gives me a point now at the center of that circle, which I'll use to create a line. So I'll double click and I'll start to type in line. And I want a line from that point, from that 0, 0 point, and I want that line to have a length. And that length should be the radius. So I also want to tell it which direction I want to draw that line. And I'm going to draw that vertically, because that's going to be my north direction, along the y-axis. And again, I want the length to be 40 feet. And that gives me a line of 40 feet. So now, as the compass increases or decreases, that line will increase or decrease with it. And I want to label north being up by using a tag. So I'll double click and type in text tag 3D. So for what I want the tag to say, I'm dragging a panel down. And I'm going to double click in that panel and just type a capital N. I'll plug that into the T for the tag. I'll need a placement of that tag. So where do I put that tag? Well, I'm going to put it on the endpoint of that line. So I'm going to double click and type in endpoint. So the endpoint of that line. And then I need a number slider for the size of that text. Make it smaller. Okay, so now we have our north direction. Now we'll need to be able to rotate the line we just made 360 degrees. So I'll double click and I'll start to type in rotate. And the geometry that I want to rotate is that line. And the angle in Grasshopper is in radians. And I like to use values of degrees. So if I double click and start to type in radians, there's a component that converts degrees to radians. And I'll need a number slider. Okay, so now you'll see that I can rotate that line, except I need it to follow the sun's path during the day, which goes actually clockwise, goes northeast first. So I'm going to double click on this slider and I'm going to change the minimum to negative 360 degrees and the maximum to 0. Now it will rotate clockwise. So that's going to be my azimuth. The next thing I need to create is the sun's altitude. I'll double click and I'll type in end so that I can get an endpoint at the end of that line. What I want to do now is move that endpoint vertically, so that will be my altitude. So I'll double click and I'll start to type in move, and the geometry that I want to move is that endpoint, and I want to move it in the Z direction. And I'll need a number slider. I'm not going to use my number slider for my azimuth because it's now negative. So I'll copy and paste this number slider. Okay, so now you see that point moving up and down. So for the sun's ray, I actually need a line that is going from the center of this circle up to that point. And I can do that by using my last line component, and that line's going to be from the start, which is the center of the circle, up to this point, which is B. So now I have a line that represents the sun, and this is changing my altitude, this is changing the azimuth, and this is changing the compass size. So let's go ahead and do some organizing here. We can name these sliders. So this is my compass, and this is my azimuth, and this is my altitude. And later on, when we come back to this definition, we want to understand that these three sliders are important. So I'm going to click on each of them and Control G to group them. And if I double click on them, I can change them to circles or rectangles with filleted corners. So I'll change these, all three of these, to circles. And then if I right click on these, I can change their colors. And I'll just use red, green, and blue for now. So that's red, and then this one can be green, and this one can be blue. Okay, so now that is our sun system. So this definition that we see on the screen represents the sun system. And I can also group this together by selecting it all and typing Control G, and I'll label this. This will be my sun system. I'll increase the font size. Okay, so the next thing that we need is we need our geometry that's going to respond to this sun system. And we're going to do that with a plane that is running along the x-axis, and it's a vertical plane. So it's going to be a plane, an XZ plane. So we'll start out by double-clicking and typing in plane. And we're going to use a plane surface. And you'll see that show up in Rhino, and it's in the XY plane. Well, I need it to be in the XZ plane. So I double click and I type in XZ, and I plug that into the plane input, the P input for plane. So now I have that plane going in the correct direction, but I also want the origin of this plane to be from the center of our circle. So I need to move it up. And to move that up, I first want to set the length and width of that plane. So I have these two XY inputs that I can use a number slider for. Control the X and the Y. And I'm just going to make my plane square. So I'm going to use the same number slider for X and Y. Okay, so it's originating from 0, 0, 0. But I want the midpoint of the plane to originate from 0, 0, 0. So I have to slide it to the left along the x-axis half the distance of the radius. So I have to slide the plane over half the distance of the x value. So I can use math for this. I can double click and start to type in division, and I'll choose division. I want the result to be half of this x value. So I'll plug in the x value to A, and then I need a number slider that's set to 2, which will always divide that x value by 2. So if I put my cursor over that result, it's half of 41 right now, which is 20.5. I'll make this value 40 just to round it off. So my result here will be 20. So now I just need to move that plane in that direction. So I'll need a move. And the direction that I want to move it in is my x direction. I'll select my original plane and I'll turn it off. So what we're finding here is that it's moving in the wrong direction. So what I'll do is I'll double click and I'll type in negative, and I will use the negative value from that result instead. So now I have this moving in the correct direction. So what this does is, as this plane increases, it increases from the origin, which I want to be the center of the circle. And I'll set that back to 40. Next, we want to create those circles that open and close that we saw in the beginning of this video. So the first thing I need to do is divide that plane surface. And to divide it, I need two components, a divide domain squared that will create my X and Y grid, or as this component calls it, my U and V grid. And then I need a subsurface, which is a iso trim component. See, it says subsurface. So my divide domain gets plugged into the input for the subsurface, and both of these components need the geometry, which is the plane surface. And now you see I have a divided surface that by default is dividing 10 by 10, and I'm going to leave that default. And I'm going to hide this move component, which is not the divided plane. Okay, so just to make it a little easier on the eyes. Okay, so I want to make some inscribed circles in these cells. So I'll need a center point for a circle. So I'll draw a diagonal line through all of these and put a point on that diagonal line to create my circle inscribed in these cells. So what I'll need is I'll need to explode these subsurfaces so I can access the points at each corner. So I'm going to double click and start to type in explode, which is actually a brep components. And I'll plug my subsurface into that, and you'll see I'm going to get all of my points at each corner. I'm going to need 2 points to draw a diagonal line. So I'm going to bring out a list item with a number slider that's set to 0. So that'll go into my I input. And my list is going to be my list of points. So point 0, and then I'm going to copy and paste this and set this to 2. So it'll draw a line from the 0 point to the 2. Now I can draw that line using a line component. And just to make that a little bit easier on the eyes, I'll hide the explode, I'll hide the subsurface, and now we can see these diagonal lines. So the next step is to find the midpoint of each one of these lines so that we can draw the circle from that point. So to do that, I'm going to use a evaluate curve, and I'll plug that into the evaluate. Now I need to evaluate using values from 0 to 1. So the halfway point is 0.5. So I'll take one of these number sliders and double click on slider and set it to rounding with a minimum 0 and a maximum 1, and my value is going to be 0.5. Okay, so now I get a midpoint if I hide these list items. Okay, so I have a midpoint at all of those diagonal lines, and I can place now a circle. Okay, so what we notice is that all of these circles are actually in the XY plane, and we need them to be in the XZ plane. So we just need to add an XZ plane in between the evaluate curve and the circle. So I'll double click and start to type in XZ, and I'll just place this in between. And those XZ planes can be not so easy on the eyes, so let's turn the preview off. So now I have my circles orientated in the correct direction. I'll turn off my lines. I'll even turn off those center points. Okay, so now I have my circles. And what we need to be able to drive now, probably the most important part of this definition, is the radius of those circles. And at the beginning of the video we mentioned that the radius needs to increase and then at some angle start to decrease. So what this is going to allow us to look at is conditional statements in Grasshopper. And to do that we'll need a component called dispatch. And what this allows us to do is have a two-way street, meaning that we can use values of A or values of B. And if you look at these, A is for true values and B is for false values. So we have to set up a function that gives us a result in true or false. So if I double click, I'm going to start to type in F, and I'll use my function that has a single variable. Okay, and that's going to get plugged in to my P for dispatch. That's going to give me my true or false. Well, I need to set up that function. So I'm going to right click on the F and bring up the expression editor, and I'm going to say that true should be for values that are x less than 200. That will create a true, x less than 200. Okay, so I'm getting an error because I don't have x. So x is going to be my azimuth, which right now is a negative value. So just to begin with, I'm going to change that negative value to a positive value. And again, I just need to plug my azimuth into that. Okay, so that's giving me, in this case, a positive 267 degrees. Well, let's make x less than 200. So we get a true. Okay, the result of my function is true, therefore that's going to use A. Okay, so we're going to be setting up increasing and decreasing values for these radii. So I want some sliders that are rounding that go from small to large values and then from large to small values. So I can start to set those up. So I'll bring out a number slider. I'll rename this one small to large. I'll copy and paste that, and I'll rename this one large to small. Okay, and remember, these ultimately are going to control the radius of these circles. So let's just pull this over, make some room. Okay. Now let's look at what these sliders are going to be used for. So the value coming out of A right now is empty because it's looking for the list. So the list, I wanted a positive value. It's really my azimuth that needs to be plugged in there, but again, that's negative. So I'm going to plug in my negative component into that dispatch list. So now the value coming out of A is the positive azimuth angle, which is 149 degrees. Well, if this is going to control the radius of the circle, that value is going to be way too large. So I need to divide that value down to get it in the range of my circles, which I think each one of these grids is about 4 feet by 4 feet. So my radius needs to be under 2 feet or under. And right now it would be 149 feet. So I'll use division, I'll double click and I'll type in division. And I'll plug my dispatch into A, and I'm going to divide by the small to large. And let's increase this value. Okay, so I need to make this range, let's say it's from 0 to a high value, say 0 to 600, because I'm trying to get this result that's coming out of here to be under 2 feet. And there I'm starting to get some small numbers out of there, 0.33 feet, 0.42 feet, 1.2 feet. Okay, so that's working. And let's get that to drive the radii of these circles by plugging that into the radius. So now that's controlling it. So let's make sure this is working for values between 0 and 200 degrees of the azimuth. So here's my azimuth. So you see at the beginning of the day, when the sun's on the north side of that plane, those circles are very small. And as it rotates around to the south, they get large. Now we need to set up, after the sun moves past 200 degrees, that those circles begin to get smaller. Let's set our azimuth to negative 200 degrees. And this will generate a false coming out of our function. And then that false will go into our dispatch, and now it will start to use the B values. So we have our large to small slider. We're going to need a function and a division, because these circles are going to rapidly decrease as we move to 360 degrees. So this is something that I experimented with quite a bit before I made this video. So I'm going to copy and paste this function, and I'm going to plug my B into the X. So this 200 will be the X value, and I'm going to right click on F and go to the expression editor, and I'm going to use some large values here. So 10,000 times 1 over X, which right now is 200 degrees, to the power of 4. Okay. And I'm going to take that and I'm going to divide it by values from this large to small slider. So I'll copy and paste this division, plug the result of the function into A, and this large to small slider into B. And before we get too far with that, let's plug the result of that using the shift key into our circle radius. So nothing's happening here. So I need to change the range of this large to small slider. So I'm going to double click on it. I'm going to change the rounding digits to 6, and I'm going to change the maximum to 0.0001. Okay, and I'm going to increase this slider. So now I'm starting to get close to the range from where I left off. Okay, we'll say that's close enough. And let's actually test this by increasing the azimuth angle. And you'll see the circles are getting small enough. So let's zoom out a little bit and test this out. So at the beginning of the day, the circles are very small and we're not allowing any light to come in. And as we move up through the day and the sun starts to hit the south, our circles increase and allow that light to come in and passively heat. And then as we move later in the day, those circles decrease.